think you're stuck with me for the final panel here. So I'll be moderating this panel on the future of climate robotics, and then invite my fellow panelists to take the stage. And as they do, they're just very brief framing. Basically, we're looking at the looking ahead and envision what the future of climate robotics might look like in the next, say, 5 to 10 years. I'll invite our three panelists, Marcello is joining shortly, to briefly introduce themselves, and after which I'll do a first round of questions and then open it up to the floor. So go in the order that I see, I guess, here. Berk, Simona, and Marcello. We'll do that order for a brief intro. Over to you, Berk.
Sure. Hello, Patrick and everyone. I am Berk from Worcester Polytechnic Institute, Robotics Engineering Department. Our lab is Manipulation and Environmental Robotics Lab. Yeah, very happy to be here. Thank you.
Thanks. Simona, over to you. Might still be on mute. I think it works now.
Can you hear me now? Yes.
Yeah.
So I am Simona Aracri. I work at the National Research Council of Italy at the Institute of Marine Engineering. I am a physical oceanographer and an offshore engineer or marine engineer and naval architect. I am working at the moment on robots that work in extreme environments, so Arctic, Antarctica, and alpine lakes. In particular, I'm interested in valuing the data that come from these missions. Of course, I've been taking care of the logistics of the missions and how we need to integrate the sensors on the robots so that the data that come out from them are going to be valuable. In the past, I participated in 13 oceanographic cruises in the Mediterranean Sea, the Pacific, and the North Sea. And now I'm here talking about climate robotics.
Wonderful to have you here. Thank you, Simona. Marcello.
Thank you, Patrick. I'm Marcello Calisti. I'm Associate Professor in BioRobotics at the BioRobotics Institute, Scuola, Superiore, Sant'Anna. I work mostly on bio-inspired robots and underwater robotics. The concept that we are using is to take inspiration from nature to create devices that then can be more friendly accepted by the environment, they can monitor better and potentially restore better environment. We developed crab-inspired robots that prove to be way more effective and environmental friendly than traditional underwater robots, and we use the same robot to start cleaning the seabed from sink and litter. So that's me.
Excellent. Thank you for joining. So I have a couple questions for you, and depending on how long we take to discuss and brainstorm together, we may or may not get to the second question, but we'll certainly open it up and invite participants to share their questions with the panelists. So the first question I'll also post it in the chat in case folks want to be able to read it and process better by reading. How do you each see climate robotics evolving beyond the current monitoring applications? So that's really the main function right now still, but it's come up a few times during the summit about, yeah, okay, there is the monitoring, and then robots can also do something about what it is that they're monitoring that may be a problem related to climate issues, for example. So what do you think we can expect in that sense when it becomes when that technology, if and when that technology becomes so mature that we can open up that other whole set of functionality? And feel free to just jump in. I'm not going to call on anyone. Feel free to make it just an open conversation between all of you.
Sure. Maybe I can go ahead then. So I really think that robots would have role beyond also very valuable environmental monitoring technologies. However, we need this scaling with robots sometime soon, right? And being able, so in order to get there, I think the key is, which is mentioned by many panelists all across the sessions is the human-robot collaboration. I think like looking into that aspect, maybe not shooting for full automation just yet, which is again mentioned many times that it is very, very difficult, especially if you want to go to manipulation or any type of interaction with the environment, with physical objects in the environment. It is really, really difficult. So if we focus our efforts over there, we can achieve where we want to be in a much faster pace, I think. And I just want to give two examples. Our lab works on waste sorting for recycling, for example. In the waste sorting field, like in the recycling field, that was also mentioned in the waste management area, like we really need to have almost pure plastic stream, almost pure paper stream, almost pure metal stream, and they have their own branches, right? In order to have a robotic solution that is fully automated and just a robotic solution that can do this from beginning to end is really, really difficult for many reasons. But one of them is that the AI system needs to get updated all the time because new objects come, others go. So the AI needs to be having some samples of those data to be trained on. So what we are focusing on right now is a solution that humans and robots can work side by side, and human sorters, while they are sorting the waste, the robot have missed down the line, they are able to automatically generate training data for robots. But in this kind of strategy, we are trying to address an area that there needs to be constant updates for the AI, but also we are not putting any additional workload for human workers doing the job. So that is one of the strategies that that we are trying to adopt. And similarly, we have a ship recycling project, and over there again, without having a human-robot collaboration, it is really difficult to have a fully autonomous solution for ship breaking, ship recycling. I don't want to go into detail because of the lack of time, but I post the link of our lab in the web, and people can reach us or check the resources over there. So again, over there, human-robot collaboration made the technology possible to deploy. And we are right now in the first prototyping stage, thanks to that human-robot collaboration. Let me stop here. Thank you.
Awesomeness. Love it. Thank you. Simona, Marcello, you want to comment on this or prefer to move to the next question, or?
I have an answer to that. So actually my moving forward paths would be like divided in 5 possible grounds. So I was thinking that one thing is scalability. We mentioned during the summit in the past days that some of the actions require like a broader scale. So like we need to have robots that need to be deployed like in mass. So like, yeah, need to be scalable. Then the interaction with the environment. So the interaction with the environment means that they're going to be able to interact, to like monitor and repair, for example. So all the part of maintenance and repair of offshore infrastructure, and why not even restoration. Then the third and the fourth would be about delicate sampling and adaptive sampling. So I think that's something that needs to be explored yet. We are working only on the first part, but the second part, the adaptive sampling, is also very important, so that like would increase the autonomy and also the value of the observations that come from the mission of the robot. And the last one would be then, obviously, in my case, a data-centric approach. So like that would include the data also at the design stage. Again, this is because like if we need to plan a behavior of the robot based on the observation that is gathering or whatever it's observing, then we need to embed a control system that is capable to do that. So as short as I could.
Nice, nice, nice. Super. Thank you very much. And for some of us who may not be entirely sure, including myself, what you mean by adaptive sampling, I'm like maybe more of a wannabe engineer than an actual what do you mean by that? Just so that we.
Yeah, for adaptive sampling, what I mean is if we are, imagine a heat wave in the water, right? If we are in the middle of the ocean and we know by the models or from satellite observations that there is a heat wave like a few kilometers, like from wherever we are, then we should be able to pilot the robot or address our observation to wherever the phenomena is happening. I mean, synoptic observations and observations that are like happening at the same time as a phenomena are incredibly rare. Imagine like how many times deep water formation has been observed in real time. It really like it's rare, incredibly. First, because some of these things happen in extreme rough scenarios like storms or windstorms, things like that. And also because like we don't know where something is going to happen. We kind of have a good idea or better idea nowadays with forecast models, but still like the scale of forecast models is not in the order of hundreds of meters, but still kilometers, as we know. So like adaptive sampling means that we're going to be able to take action and direct our mission depending on the phenomena that we want to monitor.
Right. Super. Okay. It's like responsive, dynamic, kind of, as opposed
Yeah.
to kind of static. Right. Okay. Super. Yeah. Thank you, Simona. Marcello.
Yeah, I think that I can add a few more elements to this discussion. It's very interesting. Just to put that into context, why so many robots monitor the environment? And the answer is simple, because it's the simplest task ever. So when we have a robot that can collect data, then if we want to collect environmental data, yes, of course, we can use the robot to do so. But what I saw in my almost more than 15 years of working in robotics, I really saw a pace that is going toward improved interaction, improved autonomy, a lot of different things that make me hope that we can have a real impact outside factories, outside lab. And this is the main, let's say, challenge I had in general, to bring the robot outside in the field. And the climate robotics is literally using the robot in the real environment where the robot needs to be used. And with this respect, I think that we are seeing different time frames. That's the reality for me, because we are starting to realize what works in the lab does not necessarily work outside. And this limits a lot the autonomy of behaviors that we thought it was possible to deliver immediately. And then when we start to reframe ourselves with this new frame set in mind, and then we start to include, okay, let's listen to the users, to what they really need to monitor, to what they really need to sample, to what they really need to interact with, then we can see a low-hanging fruit in front of us, because maybe doing a specific task which is tailored to the robot that we have, it can be delivered, I will not say tomorrow, but let's say in 1 year. In 1 year, we can go there. And then we can imagine also something more futuristic, as we saw during this talk. Sometimes we have biodegradable robots that are compliant with the environment, robots that can interact with different ways and become part of an entire life cycle. And this is a spectrum that is, let's say, 10 years ahead. So it depends, in my point of view, what time frame are we speaking of, and then we can see how we can add other element other than monitoring to our capabilities. And to conclude that, I truly believe that sometimes we are pushing the boundaries of what has been designed for factories and for confined and defined environments. Okay, so we are reusing the robots and we are using technologies that were taught to work in a very different setting than the natural world. But natural world is wild. It's truly wild. It's truly unpredictable. It's truly, we need really robots that really needs to adapt. And they need to adapt, I would say, not only from the intelligence point of view, but also from the material and the way that we design the robot, in a sense that maybe we have to create more living beings that have to be in harmony with the environment. So let's say robots in harmony with the environment. That's my futurable idea for 15 years ahead.
Super interesting. Thank you for that as well. Great to get all these contributions and insights. I'm gonna keep my second question for later because we have a question from Alessandro, who is addressed to all of you. Do you think it is possible to avoid the usage of robotics in environment degrading missions, such as deep sea mining? Happy to repeat that if you want. Anybody want to take that? Do you think it's possible to avoid the usage of robotics in environment degrading missions, such as deep sea mining?
I feel touched for my underwater background, Simona maybe as well, and Berk of course. So I will go immediately with that, and then we will see the response of other panels. And the point is that robotics is a technology. So this is the real truth and the sad truth in a sense. So it's a tool. How do you use this tool? In some cases, it's unfortunately not up to you that are creating the tool itself. That cannot be used for purposes which are not the one intended by the creator at the very beginning, because at the end of the day, this is the question. Even though I create a magnificent robot that goes underwater with my beautiful legs and do all good things to the environment, everyone can take this same technology and use it for underwater mining, right? So in this sense, it's a way of, as you mentioned before, the panel we saw before is an ethical dilemma, if you want, no? It's what we want to do and what we have to do to move forward in a responsible way by taking into account all these elements. There are very slippery grounds on that, but it's for sure it's not, in my point of view, it's not possible to be 100% sure that we will not apply and the robot will not be applied in such not climate friendly tasks.
Thanks for sharing. Well put.
Yeah, yeah, it is a very broad conversation, right? Like, but there are certain initiatives to establish coalitions between roboticists to prevent certain effects. For example, there are coalitions of roboticists for that are against weaponization of robots, and there are also similar ones for environments as well. So I guess regulation again can be one of the keywords here. So like public pressure, and afterwards, as a result of that, regulation in the policy area can be one of the ways of tackling this problem.
Right on.
Yeah, I agree with the regulations. often they come with political alliances in the background. Like if you think about the commissioning regulations for offshore structures, we have different ones in the North Atlantic and in the Mediterranean. We have the OSPAR and the Barcelona Treaty. So like, and that really is embedded with the political culture and nexus of like the regions that we want to tackle. Naively, to answer directly to what we can do to contrast that, like one of the reasons why we cannot contrast a priori the use of robots in deep sea mining is because there is no enough knowledge there to say, if we do this, the consequence is going to be this other one, you know? So the answer would be like, we have to beat this in time. So unfortunately, the answer is funding. The thing is, industry has more funding than research. So like they're gonna beat us to it. But if we have more funding to like gather enough information to then demonstrate that deep sea mining in a certain region of the world is gonna be deeply deeply impacting the ecological system there. Although you might say, yeah, we know, like, you don't have to do it, but you have to demonstrate it. That's not enough. So like, if we can do that, then we have a bit of hope. But I totally agree with Marcello. At the end of the day, it's very hard to control the life of your invention once it's outside in the world. And there is a lot going on, a lot of debates going on about the ethical implications of robotics in particular. I remember a few years ago, I participated in one mandatory course on ethical implication of robotics in the UK. And actually, I really loved it. It was really insightful, and it made you really think what does it mean to create something unique, highly performative, and useful? Because it means that not only scientists are going to want to use it.
Very, very interesting. This reminds me, I don't remember the exact quote from Garry Kasparov, the chess legend. At one point, he had, this was when Twitter was still Twitter. He said something to the effect that we need better humans, not less technology. For folks who are like anti-tech, saying, you know, technology is destroying everything, his point is like, no, focus on improving the humans, right? Education, ethics, values, and so on might be a good place to go in, direction to go in.
I copied that, Patrick. It was exactly the thing that I had in my mind. If people don't want to use the robot for the wrong things, it's already there, the answer, and that goes for all the technologies.
Right. Yeah, exactly. All right, we have still a few minutes left. I'll just share my second question and post it in the chat as well. Unless, no, we don't have any other new ones. Let me double check. I'd rather give priority to the floor. No. Okay, what technological breakthroughs in robotics or material sciences, AI or energy storage, you choose, do you believe will most significantly advance climate robotics capabilities by 2035? So we're talking about a 10-year timeframe right now.
So
who wants to take this?
Again, mentioned in many panels, sustainable materials came up, and there's a lot of research going on in those areas apparently, and I learned a lot from those panels. The soft robotics, so Simona can give much more insights than I can on this area, but like definitely soft robotics is a provides phenomenal advantages. They're also cheaper solutions. I guess the problem is to produce them in scale. These robots seems to be a problem, but they do provide effective solutions, safe solutions for the environment oftentimes, and it actually makes the robotics problem easier because the interaction with the environment is very less likely to break the robot. So I think that's one of the key advantages. And when it comes to AI, again, I think the key is, instead of trying to create the perfect AI that can system, whichever the application area is, that would fully and autonomously solve the problem, which is very, very difficult, right? Like people working on AI systems, I guess would agree that like bringing the system to 80% level is easy. Going to the 90%, 95%, or the last mile is really, really difficult, especially when the environment is changing, relatively unstructured, etc. So over there, if we actually spend our efforts in AI solutions that can work with humans, this is like augmenting human capabilities, right? And this also came up a lot, and it is actually something really, really concrete, that, you know, we have limited amount of resources and, you know, labor to develop these AI technologies. And if we actually combine their AI technology with human strengths, for example, in that recycling area, or the maybe I can now very quickly mention the shipbreaking project, that in the shipbreaking, there are basically decommissioned ships go to shipbreaking yards, and then they get cut with oxypropane torches. So the cutting part of this problem, we were able to solve to a satisfactory degree. But where to cut was much more difficult, because it also is a safety issue. If you cut a piece in a certain part, the huge piece can topple on top of the robot, or more importantly, can harm people. So, and it actually requires a lot of human expertise to understand how to cut. So the solution that we came up with is really, really very simple. It is basically spray painting, human experts spray painting the areas that needs to be cut, and then the robot goes ahead and you know, cuts those regions. And this really, really makes the robotic problem much, much easier for us. And that also combines, brings this idea of like, you can still scale with robots, and human expert basically allows, enables many robots, more than one robot. Basically, they can, in this way, they can just like quickly, let's say, draw the path, and then go to the next piece, go to the next piece, go to the next piece. And the cutting part is the one that takes a lot of time anyhow. So I think focusing on that intersection between human and robot capabilities is really the key for coming up with these technological breakthroughs.
Super interesting. Very, very, I'm learning a lot. I love this summit. Simona, Marcello, do you want to touch on this question? Do you want to take the conversation slightly elsewhere? What would you like to do?
I have very little insight to add. I agree with Berk that materials in the future are going to be a big technological path to explore, especially for biodegradable solutions. I think for soft robots, or Marcello might be more appropriate than me to speak about this. But I remember yesterday Cecilia talking about taking the path of exploring new materials so that they would be more biocompatible. And I know about the research that has been going on for a few years now in Bristol by John Rossiter, and they are actually taking care of creating robots that are biodegradable. And I always remember the paper Here Today, Going Tomorrow, so the title of a song. And for example, they address specifically this problem. The problem with new materials is that normally, or materials that are biodegradable, is that they don't last for very long. And more importantly, what is going to happen to the electronics inside the robots. So then the next step would be like removing electronics, as Cecilia was saying yesterday. And again, in that case, we have to find out how to match the performances of the robots that we have available at the moment in terms of data logging or like navigation capabilities, if there is no electronic involved. In the sea, you can you can leverage a lot the movements of the water for displacement. For example, if you want a Lagrangian sampling, so something that moves with the water. But otherwise, for active propulsion, you need power. And that's a big challenge for electronics. So, and after that, whether we want to embrace the material challenge or the electronic challenge or not, still today, with the capabilities that we have, the endurance of the robots at sea, for example, not only at sea, is a challenge. So.
Super interesting. Thank you for that, Simona.
Yeah, Patrick, it seems to me that we need breakthrough in everything, right? Because we need better material, more compliant interactions, better batteries, better reasoning, and I think that all things considered, it distills everything on this concept for me, at least. That we built robots, we built algorithms so far to do very well what humans are not capable of doing, calculating very quickly, lifting huge weights, and so on and so forth. But now, creating robots that needs to go again into the environment, we are asking completely different things. We are asking to be more adaptable, in this case, in a sense of being capable of negotiating unexpected situations, of be capable of reasoning, of being part of an environment that interacts with other animals, plants, and even with the environment itself, with waves. So I think that this is the breakthrough that we need. The thinking redesign. So we need to let's say, redesign the robots in a sense from scratch, where all the elements will come together and say, okay, let's think of not using any more rigid materials. Let's use compatible materials. Let's use the fuel cell that Bristol is using, a biological fuel cell that exploit how to harvest energy from the environment. Let's make the body of our robot in a way that can exploit waves energy instead of going against it, and so on and so forth. So since we need breakthroughs in everything, we need a breakthrough in the design, conceptual design of how we think our robots. Yeah, I know it's not an answer basically, but yes, that's mine.
And goes back to what we're trying to do with thank you. I mean, that's brilliant. Don't act against the wave. Use it as an enabler. That's beautiful. I love that. And it goes back to some of this reference we've made over the course of the summit around these design principles for kind robotics. And I'll definitely coming back to each of you and so many of the other panelists and speakers as well for your kind of peer review of these guidelines based on everything that you've shared and the deep insights as well. All right, we've got a few minutes left, and as we like to do here at the summit, we like to close with some hot takes. So again, provocative, really, really provocative, not mildly sort of provocative that we're going to remember it by this time next year when we have the 2026 summit. We'll say, oh, remember when Berk and Simona and Marcello finished, and that was nuts, right? People are going to want more. So that's my challenge to the three of you in this last final session of the Climate Robotics Summit. Any contrarian opinions, provocations that you want to leave us with? Nobody's going to say.
Yeah, very high bar. But yeah, I think we should avoid having blanket statements about the impact of robots on the human workforce. I really think that is something that we should look into in the micro level. And there were actually many great examples that in the other panels, people were like panelists were discussing. For example, in the agriculture panel, I guess Marcello was moderating that, and there were many cases that was specific to the agriculture robotics problem that would not like specific worker implications that would not translate to, let's say, waste management, that would not translate to, let's say, underwater monitoring. So I think that some concerns of public is legit. And it is true that we need robots for scaling the solutions. We need them very urgently. We need them right now. So definitely robots, yes. It is true that in some areas, there are worker shortages and robots will chime in. In some areas, there is not, you know? So it is really like specifically specific area dependent. And we, while designing our technology, we really need to have a focus on the specifics of the area, of the both needs and characteristics of the workforce in that area while designing our robots. Thank you. Is it provocative enough?
We'll see. Depends on the other two. How Simona and Marcello do. You're competing here. Very well put, though. Very, very well put. Definitely resonates a lot. Simona?
I'm not sure I have a ready answer. Anyway, the question that I always ask myself when I listen to scientific talks at conferences is, how is this useful? So please ask yourself this question when you put together a new technology, and make sure that whoever is listening to you has idea of what you're going to do with that. So why is this important? Why is what you're doing is important? Why do I care? Why does anybody else cares? So I would love for everybody to keep this question in mind, whatever is the challenge that you want to embrace, you know.
Very, very nice. Very nice. I think Simona's in first place right now. Sorry, Berk. All right, Marcello, you have the last word.
Yeah, let's hope that I will win the provocative contest. So when I started doing underwater robotics, I started doing that because I wanted to go into the unexplored. Okay, so that was my real goal. So looking into the depth of the ocean that is unexplored and see what is there, because I'm fascinated by animals and I wanted to see the craziest animals that this planet created. And then I realized that beside these animals, there were a lot of litter. There were a lot of plastic elements, of aluminium elements, of wastage on the seabed. And that's what shifted my robots toward restoration. And my provocative take is, I really hope that we will not do this meeting. We will not reach to the 5th edition, let's say, because the mentality changed. And this is using your statement, Patrick, basically. If we don't need climate robots anymore, this is the most successful outcome of climate robotics in general, to suicide itself. Because basically we gave enough information to people, we did enough restoration actions, then we don't need climate robots anymore, and we can use our time to explore even more and further in a sustainable way. That's my hot take.
Very, very nice. The end game for climate robotics is no longer the need for climate robotics. I can sign up to that. I think you tied for first place, Simona and Marcello. So that means, Berk, you have a whole year to think of, something that could give you the edge. But thank you all very, very much. Please all join me in thanking our wonderful panelists with this final session with a digital round of applause. Thank you all again very, very much.
Thank you very much, Patrick, for organizing that, and Berk, of course. It's an amazing initiative. I'm really happy to be part of it.
Thank you. It was awesome to be part of this.
Thank you all. And speaking of, yeah, it's a huge team effort to pull off something like this. It is a heck of a lot of work behind the scenes. You're seeing the tip of it, and so I want to hand it over to my good colleague Heather to lead with the closing, and then Berk will take us to the finish line. Heather.
Thank you, and thanks for a great panel, everyone. I really have very much enjoyed today. I feel like I learned quite a bit from everybody, and I'm going to have to look forward to some of the videos. I really want to listen to the ethics one a little bit more, something I do in my day job. So today, I'd like to take a moment to just spotlight some people who've made a big difference here. And I can't spotlight if your video is not on. So the people who have team listed, who are team members, you've had your video off, and I'm hoping that you're not shy, but I'd like to just bring you to the front of the stage just to give you a warm thank you. I'm just going to add some spotlights, so just bear with me while I add a whole stack of people who've been doing, and Hudson. I'm going to need to find you. Stefano, it would be really lovely to see your face. Please and thank you. Look at me begging to see people's faces. We just
Beautiful.
Stefano, and we need and Hisio.
And Rishav, although, oh yes, sorry, hi Rishav.
And I thought I had put in Hamza, but he's not here. So Hamza, we have to go find him. Stefano, thank you so much. I'm sorry for the whole community radio here. Apparently I can't add more spotlight. So maybe
Yeah, had enough
take
stage
you
time.
out. All right, thanks, Patrick. Bye. How rude was that? I mean that in the warmest way. Add spotlight. There are two people who are not spotlighted right now, so I'm very sorry. For some reason, I'm unable to spotlight Hamza or Ezekiel. I just want to take a moment to say that this summit was the core organizing team. And then Axel and Hudson, they did an incredible job designing the production, following up with you, doing the agenda, across all of the details. You can't even imagine how many details they had to be across. Herding cats. They did an incredible job producing before the show even started. And that's why I'm speaking right now, because they would never give themselves the kudos that I would do very loudly. So can we just give a warm regards to Hudson and to Axel for just doing an incredible job. It's their first time doing digital production for this kind of thing, and just congratulations. And then the rest of the team who joined to support in the last little bit, Shilpa and Rashiv and Hamza, who's not on screen, and Julia, I can add him, I think. One second. I can't add Berk. Can I kick you out for a second? I'm so sorry, Berk. Just for a second. Thanks. I just want to give them.
If you want to add somebody else, kick me out.
He hasn't put his camera on yet, so there's just one more person. Sorry, I feel like they did so much in terms of all the notes, all the follow-up and everything. And so we are a really volunteer-led organization. And so just a warm regards to everybody and congratulations. And so for everybody who's seen the notes or has questions, after this event happens, they're still going to volunteer. Some of them are going to be doing videos, some of them are going to be sending follow-up emails and stuff. And so when we talk about community radio, it really is this team. So just warm regards to everybody and thank you so much. And maybe we'll send it back to Patrick. If you on the team, we're also going to have a debrief and learn and make lessons about what we learned on this. If you as participants have lessons or things that you think that we need to improve on, please don't hesitate to let us know, because next year we'll make it rocking as well. But back to adding some people. So I'm just going to remove some spotlights. And I am not as talented as my friends here. Sorry, Axel. Move your spotlight, add Berk back in. There we go. All right, thanks everybody.
Thank you. Thanks so much, Heather. Thank you all, team. Phenomenal job. Just incredible teamwork in the backstage. Phenomenal. And thanks for all the great humor as well. Beautiful. Berk, do you want to close?
Sure. I like, again, thank you so much, Heather, for like leading the whole tech team, and thank you so much for all the volunteers. They worked a lot, And I should also say that for our student volunteers, this was at the finals week. So there were cases that, they basically finish and then run to their exams and then run back. So that was a phenomenal effort, really. And we actually started organizing all these I think on September. And in that core organization team, Simona, Stefano, Marcello, who also all of whom also moderated many of the panels, but also finding the panelists and connecting people and everything. So that was definitely a very an effort that took months and months until we come here. And of course, Patrick is the life source that really connects all this network and making all this happen. So thank you so much, everyone. Yeah, so that's my final.
Thank you, Berk. Thank you all for leading and doing the vast majority of the work in organizing this year's event. Truly appreciate it. Thank you all for joining us. Thanks to our speakers, sponsors, supporting partners, organizational partners. Have a lovely, lovely weekend. We will make all the videos available as quickly as we possibly can. Let's continue the conversation online. We've got a Slack group. We're more than 500 now. So many different walks of life and areas of expertise and interests represented. So let's see you all there. And thank you again to everyone who made this happen. Be well, everyone.